Dave Richards. Welcome to another episode of Old Steam Powered Machine Shop. This video is number 23, and it's going to be concerned entirely with a sleeve job that came in the shop. An engine that belonged to the Florida Flywheelers machine shop crew that they had procured to run their line shaft with would not run when they got ready to run it, and they had the magneto gone through and it still didn't have, it seemed like it had much compression. So they pulled the piston out of it, and at some time in its life, actually a while ago, the retaining bolt for the wrist pin got loose, and the wrist pin got loose and gouged up the side of the cylinders really bad. So what we decided to do was sleeve it and bore it back to standard size, and I was able to find a Melling sleeve. It's 5 3/4 bore, and the sleeve is 17.5 inches long. It could have stood to have been another ½ inch longer, but it's the longest thing they had, longest sleeve they had. So it worked out really well, and bored it in the boring mill. It's not really a steam powered project. The boring mill is kind of too new to be in the 1925 groove here, but it's old machine work, and I thought you'd enjoy seeing how I ended up doing it. It's just basically a lot of cuts through the cylinder, but you stop at the end. You don't bore all the way through it, and you leave a step for the sleeve to bottom out against. And you have to plan that properly so that you got just a little bit of the sleeve sticking out of the end when you get it installed, so you can trim it, and then bore that whole thing back out to fit the piston. Let's see, it turned out pretty well. I'm going to ship it back to them here probably next week, and also had to make a wrist pin for it. And we had some real good comments on the last video. If you have time, you ought to scroll through them and look at some of them. There were some great stories in there. I don't know what went on in that video that triggered that kind of response, but we're getting a lot of people that are taking the time to write out a story of their father or their grandfather, or when they were really young, in regards to this kind of a shop, steam powered line shaft work. And the one I love is the one about the laundry. A gentleman wrote me a really long response. It was the whole story of when he was a kid, how he ended up being the engineer for a day when the regular engineer was waylaid by an accident, and he had to start the boiler up from stone cold and get the plant going again. And his run-in with the boss who wanted to start the engine up before the steam was up, and how he had to go after him with a hammer to keep him away from the engine. And there's a lot of other really good stories in there too. But that's what this channel is about. Just talking about steam power, flat belt drive power, and line shafts. So I appreciate everything. All the comments and subscription, and the next video I'm going to show you some clips from our road trip that my friend Jim Mead and I took out to Princeton, Minnesota, to pick up the big Richards Ironworks engine, and we got it back to the shop, and we'll show you about that engine on the next episode. So we'll get to machining the economy cylinder. Thanks a lot.
This sleeve is just cast iron. It's a real good grade of cast iron, a lot better than the original surface. It's centrifugally cast. You know, it's a modern sleeve, and it's ground on the outside, and it's amazingly accurate for what it is. So what I've done is I've got 6 points to measure. 3 this way, and then turn it 90 degrees, 3 that way. We're going to average those out to come up with an outside diameter to bore the block to. So we're measuring across here, and we get 6 inches plus 4 thousandths. And 6 inches plus 4. Six inches plus 4.5. Well, right on the line, plus 4. About 3.5. Three and a half. Okay. 22, 4, 8, 12, 16, 19, 22, 22, and 23, 23 and a half. 23 and a half. Okay, and so you divide that by 6. I'll have to use my calculator. I'll be right back. Finish cut on the cylinder. That's taking off just a couple thousand. Got the final pass run through here. I don't know if you can see this, but the feel involved with the inside mic is you start out with it too big and you work it each up and down till it comes tight in both places, and then you slowly push it in till it lines up, till it centers up, and it'll go past. And then you crank it a little more until you crank it out until it just, you find that sweet spot in there in between the two oscillations. So it just slides through. Six plus 4.5 thousandths. This measures when we averaged out all the measurements, 6 plus 4. So theoretically, this should slide right in there. But of course, in the real world, it doesn't. I mean, it'll start, but I've learned from experience, when you got a sleeve this long, by the time you get that halfway in, it's going to go really hard. So I'm not going to do it cold. I originally wanted to, because I didn't want to mess up my setup here. It took a long time to get this lined up correctly. But I'm going to put it in the oven and heat it up to 450, and the sleeve will just slam down in there, clear to the bottom. There's a step left in the bottom. It's not bored all the way through. I'll show you, give you a shot of that in a second. So that's just slightly under 17.5 inches. So it should leave about 1/4 of an inch of the sleeve sticking up. So then we'll put it back in and go through the whole lining thing again to bore it out to fit the piston. Okay, the cylinder's been heat soaking in this oven here at about 475 for about 10 minutes. And I'm going to pull it out. It's standing up straight. And got the sleeve here. Got it oiled up. And definitely won't need any kind of retention compound on it. It's going to be tight. When you start that in there, it may drop right to the bottom. You may have to tap it in a little bit, or you may have to drive it. So I got an assortment of hammers here and a hunk of steel and a piece of wood. The important thing is to get everything arranged, because if that goes in there and starts to cock sideways, you got about 5 seconds to straighten it up and get it down in there, or else the sleeve is going to heat up and expand and it'll be stuck in there. And if it gets stuck in there, it's got to be cut out. So this is kind of a white knuckle thing. Bingo. Okay. We'll let that slowly cool down and we'll put it back in the boring mill. The cylinder with the new sleeves back in the boring mill. I got everything tightened down loosely, and we're lining the cylinder up with the boring mill. And it's really hard thing to do because there's no real good way to do it. You can't get a dial indicator in here very well, and I've found that one of the easiest ways to do it is just with a feeler gauge. I've got the boring tool in here backwards and backed it off away from the surface about 3 or 4 thousandths, and you just measure it on the 4 corners. And I've got it so a 3/1000 feeler gauge will just go in there all the way around, And at this point, it doesn't need to be terribly close, because when I go to the other end and move that around, it's going to move this. I've got these two angle plates moved in here tight against it. So it's just a matter of seesawing back and forth and checking it. There's the first pass through the sleeve. Just a trial cut to see how we lined up. It's a long cut, a little over 18 inches. We're running 80 RPM at 8 thousandths per revolution feed. That works out to about 150 feet per minute. On cast iron, that's about in the middle of the speed range. First pass went through in fine shape, so we're gonna give her 20 more. So that would be 10 thousandths on a side. That's 10. hone it a little bit with hand hone. Such a long bore, it won't fit in the honing machine. Lubricate the hone a little bit with some kerosene. $5,750. And the money. So it gives you 4 thousandths clearance. Got to drill out the drip lubricator hole through the sleeve. So center it up. The center drill just kind of pilots on a 1/4 inch pipe tap hole, and I'll run that down through there to sort of center it. This is the igniter port, and the sleeve has gone through there and covered it. And this oval port should go all the way through the sleeve. So I got a little pilot hole drilled in the sleeve down there, and I'm going to go through it with this hole saw, because I don't want to use a drill, because I don't want it to break through the sleeve that's curved on the bottom and catch and cause problems and maybe chip out the sleeve. So I'm going to take it real easy doing it this way. I keep changing my mind on how I'm going to do this about every 10 minutes. Okay. Doesn't like that right now. That's it, right there. You can see that, but I can open it up the rest of the way by hand. heavy on the tail end, on the lead end. Set the tailstock over one more time. Try it again. I've taken small cuts off of this and tweaked the tailstock adjustment. So I got this right on the money, both ends. As good as this old machine is going to do. So now I got to take it down to hit the number at 1.257. Radius color, high-speed steel. That's all I really want on it right there. It's the same as the original. Okay, here's the finished deal. Polished it up a little bit. Honed this with a straight line rod hone with a piston stone in it. Cleaned it up. Probably got about a 1/2,000th clearance. I think that's what the boys want.